I would say.
Yeah. All right. Audio is active. Video is active. So 1 more minute.
Ventilator is entering my microphone. That's okay.
Almost.
Shut up.
Almost. Yep.
Okay. All right. So let's start this meeting officially now. So good evening, everyone. I hope sound and picture quality are okay at your sides. At our side, it is in any case. So welcome at our second online PHPBenelux meetup. I'm sitting here in a room together with Michelangelo van Dam, our president of PHPBenelux. And we do our best, of course, to coordinate everything from here. So tonight we have two speakers. David McKay, who will talk about kick-ass Laravel development with Docker. Then after almost an hour, we'll have a short break. And then Mark Baker will take over and he will talk about looping the loop with SPL iterators. And finally, thanks to Michelangelo and Into IT, we'll have some things to ruffle during the closing notes. Okay. There are many thank yous actually to make this happening. And it's basically all our PHP community in Belgium, in the Netherlands, and Luxembourg, although that's really small. Also, of course, a big thank you to our speakers who are happy to give their presentations here. So, as I said before, it's David McKay and Mark Baker. And then finally, our sponsors, our only and main sponsor for tonight is Into IT again. Yes. Who provided the meeting room here and is doing a lot also for the logistics. Okay. And what shall we do?
And the elephant.
And the elephants, of course. The elephants are also in the room. Okay. Then I would say, without much further ado, let's start our first presentation. Here. So David, you can take over the screen and let's go.
Okay, I am sharing my screen.
Yes.
Okay, so everyone can see kick-ass development environments with Docker. Can you just confirm? Yes, thank you, people. All right, let's start with about me. I am a developer advocate at a company called Equinix Metal. It's a very recent rebrand. It was formerly called Packet. So if you're familiar with Packet Bare Metal Cloud, this is our new name. What's a little bit more interesting than that is I've been working with Docker and Kubernetes now for around 5 years. And I want to try and distill some of that knowledge and experience here today so that you can have a better development environment with these tools. I'm also a big fan of, operations and DevOps and Salt Stack. So, I love to talk about these things. That very much a big fan and proponent of event-driven systems and event sourcing. And I enjoy working with esoteric programming languages, currently Rust, but I'm also a big fan of Elixir. All right, now I always like to start this talk with a little bit of time travel because I feel that every talk is better with a bit of time travel. And I like to start, or at least travel back 20 years, because it's better than now, of course. But this is when I roughly started developing professionally, at least. This is when I had my first role in an organization and somebody was actually paying me money to write code. And our development environments back then were not what they are today. I'm hoping a few of you are looking at this list of file names here and getting a little bit of nostalgia, if not palpitations. But, we all worked on a centralized development server, usually from the same subversion or CVS checkout. And the way that we would work would be to rename files with dates, add our names if we were working on the same bit of code at the same time. And it was just a very, very painful experience. And things went wrong a lot. And if I'm being completely honest, this wasn't just development. Continuous integration and delivery were exactly very prominent back then. So my production server actually looked a lot like my development server, and we would just move files around, the good old days. Now, things did eventually get better. There is a happy ending to this story, but it did take a long time. Puppet wasn't really a thing until around 2004, 2005, I believe. But it brought with it some new concepts and ideas that were kind of novel for the time. And Chef, I'm not going to forget Chef. Chef is just out after Puppet. They're both very similar tools that do the same thing, but I do have a little bit more of a fondness for Puppet. And the main thing that these tools were trying to get us to do or adopt or evangelize back then were the idea that we could have a sense of parity between what we ran in development versus what we ran in any other environment, but most importantly, production. It was very, very common 5 years ago still, 15 years ago definitely, that, the version of the operating system would differ from development to stage into production or pre-production, etc. Not only would the operating system be different, but you would have different versions of packages, sometimes even completely different web servers, different firewalls. Really, it was a bit like the Wild West back then. And that was because all of these machines were provisioned and configured and maintained by a human. What Chef and Puppet got us to look at was automation, configuration management. Can I declaratively define what these machines should look like and use that for all of my environments? And I wanted this. This would have got me a lot more sleep back in the day. Now, there was a problem with Chef and Puppet. While I do like Puppet and, persevere with Chef at times, they were a little bit clunky. You had to learn either Ruby or their very crazy weird DSLs, which was close enough to Ruby anyway that you'd probably just want to learn Ruby. But they weren't familiar to people that came from a background of writing in C style based languages. So that was a little bit frustrating. Now we go forward a few more years. We're now looking at tools like Vagrant and Ansible. What was this? 2011, 2012, maybe around then. And these tools tried to take what Chef and Puppet done, but just replace some of that DSL. And the Vagrant was still Ruby based and still had a very weird configuration language. But Ansible came out with the concept of writing everything in YAML. And while we all joke about writing YAML these days, it is simple. If you work with simple YAML, it's very simple to reason about. And that is a very good thing to strive for. Now, the problem specifically with Vagrant, and I know a lot of teams are still using Vagrant in 2020, and that is fine, right? You're still getting some of this parity that we want. but you are losing a little bit of time, right? Provisioning a Vagrant machine can be quite long. I used to spend a lot of time at our office back when that was a thing too, saying, oh, it's broken, or you have to run a Vagrant destroy and then run a Vagrant up again. And you're talking, depending on how much is going on with that provisioning step, of taking that developer and telling them to go away for an hour or sometimes longer. Vagrant virtual machines can also be rather RAM intensive. And if you have to run more than one of them, that can be quite demanding on your machine. Vagrant has no way to promote things to production, really. So it is just a development tool and only a development tool. That is good in some regards, but there's no way to take that parity that we want to other environments. And because Vagrant is a fully fledged virtual machine with an operating system, there's still a configuration management step. We still need to tell it which version of PHP we need. We still need to tell it which modules we need, etc. And some of that can't be avoided, but we're going to look at reducing that complexity. All right, so how long does your Vagrant uptake? I'll give everybody 20 seconds if they want to type in a number. Anything less than 10 minutes, and I do not believe you whatsoever. You cannot bullshit a bullshitter. But feel free to type something in. And if you're still using Vagrant, I would love to have that conversation too. And hopefully this talk will move us away from that. All right, nobody feeling brave with their Vagrant times. That's all right. So what we're going to focus on today is Docker. How can we leverage Docker to produce really good, fast development environments? Now, if you're not sure what Docker is, that's okay. Docker is just a tool that allows us to package our application. It's one of the most important things about Docker. Normally, when people talk about Docker, they want to come down and talk about containers and security and isolation. But really, one of the most special things about Docker is the ability to bundle our dependencies into something that is distributable. A container image is something we can promote through environments. And it's probably the most important thing. Security and containment shortly thereafter. And the things that we want to take a look at are just, how do I build a container image? How do I run a container image? Talk about that delivery bit. And we're going to fly through those first three things, right? I'm going to assume some of you have experience with Docker now, and we don't really need to get into the very, very essentials. We're going to spend most of our time today talking about orchestration using Docker Compose. And then we're going to get quite Laravel specific at the end of this session, based on some work that I've been doing over the last month. And we'll talk about that shortly. Okay, so what does it mean to build a container image? Well, it means that we have to provide a Docker file for our applications. And the most important thing here is this from statement that we have highlighted first. Whereas a Vagrant, we would specify a base operating system and provision on top of it. We do the same in a Docker file. You can see here, I'm just saying from Ubuntu 17.04. And now I have this Ubuntu system with all the command line tools that I'm already familiar with, such as apt. Next, we have to do still some configuration management, but not a lot of configuration management. And we can just say here, well, we want to install the PHP CLI using apt, tools that we're comfortable with, and it goes away and does it. The following thing we need to do is then we have our base operating system with our dependencies, is we have to put in our own code. Docker does that through copy commands. We say, hello PHP, where to store it in the container. We can set a working directory, which will be used by our entry point and our command. And then we set our entry point and our command. This is not YAML, but it's still equally simple. The Docker file syntax is not complicated. There are only a few tokens that we really need to understand, and the majority of them are on this screen: from, run, copy, and command. Now, I do apologize, but entry point and command is one of the most confusing things. It comes, or you have to try and explain to anyone that is trying to understand how to write their own Docker file. And there's a lot of confused faces as how they even work. Excuse me. So I'm going to do my best to explain this in 20 seconds. So entry points and commands. A command, when it is inside of a Docker file, is the command that is run when you do a Docker run. If you provide an argument to the Docker run command, that argument will override the command inside of the Docker file. However, if you provide an entry point and a command, then the entry point is the command and the argument gets relegated to an argument to the entry point. And if you provide an entry point on the command line, the entry point within the Docker file is discarded completely and will fall back to the command within the Docker file, unless, of course, that is provided on the run command as well. Now, it's very, very confusing. The entry point and the command, when you have an entry point on the command line, the command inside the Docker file is also disregarded and you get nothing. Now, I don't expect you all to take all of that in. It is a pain in the ass. I'm really, really sorry. It's just something you're going to have to get familiar with. The best thing to do is to always use the entry point and command within the Docker file and only override it on the command line when you absolutely must. Right? This should be your break last button. This container image I built to do this one thing. Keep that in the Docker file. If for whatever reason you need to get into debug in a Docker file or a Docker container or whatever, then you can provide the overrides. Okay, so that is building images. We provide a Docker file, we run Docker build, and we can do Docker run. Now, what is actually happening from a virtualization point of view when we run these container images? Let's take a look. Oh, I'm not going to get the window I want. I'll do it this way. Okay, I think you can see my screen. So let's make this a little bit bigger. Oh, sure it's struggling. So here, if I can get a thumbs up that that's okay. If I don't see one in a few minutes, I will make it bigger, but in a few seconds, more likely. We can do a Docker container run. And this is going to run here a node image version 10, and I'm going to run the bash command. So you can see I'm providing a command on the end. I'm also providing a couple of arguments to the Docker container run that allow it to be interactive. This just means it's going to assign a TTY, and I can actually interact with this container. Now, when we talk about virtualization of a Docker container, we're talking about something in Linux, primitives, called namespaces. And these namespaces are really the only thing that are virtualized inside of a container. There is no hypervisor when you run Docker containers. The caveat being I'm on a Mac, so there is, but let's just disregard that for the concept of today. Now, I can run ls/ here, and you see that I have a Linux file system. If I just split this terminal and run ls/ on my host, you'll see that those are completely different. So that is called a mount namespace. The file system that my container sees is different from my host. We also have virtualization or namespaces that affect the networking of this machine. I don't know how to view networking information on a Mac. I'm a Linux user, but this is not my networking information from my host. This 172 is actually a Docker network. And there are more namespaces here. In fact, I could do anything I want. I can touch files. I can delete the entire root directory. As long as I'm in a container, nothing bad I do will ever reach out or affect my host machine. We can even change the host name inside of a container. This is what you see here on the command prompt. You can see that the host name here is this AF thing. And on my host, it's actually completely different as well. Okay, great. So when we talk about virtualization, we do not mean hypervisor. We only mean Linux namespaces. That's really important to understand because it means that there are very little CPU memory overheads that we would normally get with a hypervisor. And there we go. So that's a Docker container. I didn't build an image, but we are going to look at that in the Laravel specific stuff. So there's no point in me repeating myself just now. But all you really need to understand at this stage is what a container is, Docker files, and how we build them and how we run them. You can see that it's quite easy and hopefully painless to get started. Okay, now the big or the larger section of today's talk. How do we compose services to provide real-world development environments for working with containers? Now, this is going to be PHP specific because this is a PHP event, but our applications do not look like this. They're not just PHP on its own. In fact, our PHP applications usually have a whole host of dependencies that we'd either need to install in our machine or provision through our virtual machines that we can simplify with a container-based workflow. So whether your dependencies are Elasticsearch, Node, RabbitMQ, anything else listed on the screen, in fact, any software anywhere probably has a container image these days. And the tool that we use to provide these environments is called Docker Compose. And the things that I want us to walk away with a little bit of knowledge on today is how do we satisfy these third-party dependencies? I'm going to talk about something that I've been promoting over the last few years, which is the Docker shell pattern, a way for building interactive development environments using containers. And not very applicable today, but very important to remember that the 12-factor manifesto, the way we build environment ubiquitous apps, is very important to container-based workflows because of the parity that we want. One of the things that we should really strive for when building our applications with containers is that we build that application once. No matter how many environments, staging, development, pre-prod, QA, performance testing, anything like that should always use the same container image. And you should not be building for development and then building again for staging and then building again for production. And there are ways that we can achieve that. Okay, so what does that compose file look like? Well, the first thing is YAML. And the first thing we need to do in that YAML is specify the version of the compose syntax that we wish to use. Now, this is generally, excuse me, this is generally where people complain at me and go, hey, but there's a much newer version of this. There is, right? Version 2.4 is actually an older version of the compose syntax. Excuse my dog. There is a 3.7, I believe now. However, that is very much tailored to deploy into production. And I do not feel compose should be used for that. There are actually a lot of advantages to using the older syntax. What I would say is it's not that we're using an older version, it's that we're using another version for a very specific workflow. And something that Docker did at the start of the year was produce the compose spec. The compose spec is where they relinquish control of what compose was actually aimed to do, and have opened it up, open source with open governance. And I would like to think that version 4 or later version 3 will then come back to support the development workflow where it is suited best. But right now, who knows? All right, so now that we have the YAML file to specify the version, we actually need to define the services that we need Docker Compose to run to spin up our application. Now here we're specifying that we want a PHP service. We're specifying the image. So I'm not using Ubuntu 17.04 or Ubuntu 20.04. I'm actually just using the official PHP image and specifying the version that I want, which in this case is version 7. I then can expose those ports to my local machine. So I can say ports and then 80:80. Now, of course, because that is a low port number, I would have to be root. You may wish to use 80:80:80. Either way, on the left-hand side, you're specifying the local port, and on the right-hand side, you're specifying the container port. So map local port 8080 to container port 80. Because this is a development workflow, we're also going to do a volume mount. That just means that we're going to mount the dot directory, the current directory, into /code within the container to give me a system, or to give me live reloading as I make changes. By using a volume, we can change the code on our local machines, hit save, and it will end up in the container, and we can just refresh our application to see those changes. This is the feedback loop that PHP developers were used to. Now we can also add other services. Here, I'm using an example where we may wish to expose a database to our PHP application. I'm using MariaDB. This can be configured through environment variables. So I'm just specifying what the username and password should be when I wish to connect to MariaDB. What's really important about this kind of configuration within Docker Compose is that the host name for speaking to this database is database. Whatever the service name is, Docker Compose automatically provides service discovery based on that name. So my database could equally, if we were doing something a little bit weird, request http://php, and it would find our PHP container. Okay. Now, this is where and why we're talking about version 2.4 today. Now, version 3 does support health checks, which means that this bit here in the orange, the health check, where I specify that my PHP application is healthy if port 80 is open and accepting connections. Version 3 supports this depends on syntax like this, which is a list. And that just means that it is going to orchestrate the starting order of the containers, but it doesn't actually leverage the health check that has been specified. It doesn't wait until that container is healthy before starting any subsequent containers. And this is where we get a little bit of disconnect between, yes, we want parity between development and production, but it's really important that we understand and appreciate and respect the development workflows are very, very different. When I spin up my local stack, Vagrant up, Docker Compose up, or even just Docker run, what we want is a system that will do everything it needs to do to get into a healthy state for me to write code and see those changes instantly. That is really difficult to do with the Compose version 3 because it doesn't do health check based dependencies. And I'm going to show you an example of this when we dive into the code. Now, the way that we want to work, and I'm very, very passionate about promoting the idea of a Docker shell, and it's that I really want this to be as frictionless as possible. And what I mean by that is I want to take the same workflows that you already have today, with or without Docker, and make them work with containers. Nothing should really change. You should still be able to run composer install. You should still be able to run artisan test or migrate or seed, etc. But it's a little bit more difficult to do when everything runs in a container and it's not necessarily available to us on our normal command line without providing a little bit of tooling. Then you just need to know how to do that little bit of tooling. And the Docker shell is the way that we can give you that same environment. There's also the happy side effect here. And if you have people on your team that just don't want to install Docker, don't want to work with containers, are very happy to run with things locally, well, I wouldn't encourage it. I still want these same workflows to work for them. Now, by using the Docker shell pattern and moving away from working natively on a host, the benefits that we're getting immediately are first, that any modules or system level, kernel level dependencies that we put inside of our composer.json, like we need this extension, those can be satisfied as part of the container image build, right? What I see a lot of people doing is running composer install with ignore platform requirements, which means don't check if my system has these extensions. I know better, just run it. And that can end up in very weird situations as you ship to production. We're really going to strive to work natively but in the container and give you all those perks and benefits of a container native workflow. And 12-factor, there's no other slide on this. This is it. Because I'm not really going to talk about it. I think we've all read enough on the 12-factor manifesto. If not, the website is online. The reason I'm not going into it today is because Laravel is most of the way there already. Everything is configured through environment. And that's the most important thing when I talk about 12-factor and container native workflows, is that if you are working on an application where you have a dev.yaml or dev.php and a prod.php and a staging.php, and your environments are configured within the application, this is the number one mistake or challenge that we have to get out of before we really deploy with containers on Kubernetes and anything like that first. Because remember, we want to build the image once, which means we run the same image in every environment, and we have to inject that configuration through environment variables. So, and like I said, Laravel does this really well, and we'll take a look at that also. All right, so all the bits covered. I'm going to give you some quick tips, and then we'll dive into the Laravel kind of specific stuff with some work that I've been working on lately. Okay, so there's a cool trick with Docker Compose, and what I see happening time and time again is people reuse port numbers across their Docker Compose projects. If you're working in a microservice environment, it's very convenient to use port 8080 or even just port 80 for all of the services. The challenge there is when you run Docker Compose up, you're going to get a port conflict and you have to go and shut down the old one. And one of the easiest ways to get around this is just not to specify a local port, just specify the container port like so. Now, it does mean that you're going to need to add a make target to open your web page for the application, but that's relatively trivial to put together because you won't know the port number up front. There is, again, the more Compose environments that we have, you're working with a very limited networking space on the Docker Bridge network, which means you might get away with spinning up 10 environments or a little bit more, but eventually it's going to run out of IP address siders that it can create for each Compose project, and you have to kind of shut them down. So it's really good to get in the habit of running Docker Compose down, if not daily, at least frequently. Now, Docker eats up a lot of disk space between images, volumes, databases, caches, build caches, all of these different components. Do not be surprised that if you run Docker system print on your machine, you're going to free up potentially hundreds of megs to dozens of gigs. And I've actually seen a tweet just yesterday where someone ran it for the first time in a month, and it spared 500 gig. 500 gig of your disk could be potentially being consumed. So again, get in the habit of running Docker system prune and keeping that disk clean. Now, this will be hard to visualize, but when we take a look at the Docker Compose file, what you will see is that when we have a 12-factor application, we do need to provide a lot of environment variables to configure and tune the application, from things like the database host, the username and the password, maybe it's the number of connections we run to accept at one time, pool size for database connections, like all of these things that we do need to tweak have environment variables. And that can be a little bit cumbersome, especially as some of them may be repeated across multiple services within your compose file. So a really good way to get around that is to use env file. And I have an example of this also. Now, there are a lot of official images which are based on Ubuntu and Debian images. You just got to be careful there. The size is a little bit large. Now, the more container images you're building, the more of a problem that becomes. Now, Alpine has been around for a few years now, but it is a Linux-based system in under 4 meg, very similar to BusyBox, only it has a really good package manager called EPK. Now, using that as a base image is going to save you a lot of valuable disk space also. So I recommend that. There are some caveats though, when I say, hey, go use Alpine, there are Alpine variants of a lot of official images. The one thing that always trips people up when they adopt Alpine though, is that it's not glibc based. It uses muscle C. So if you are compiling PHP extensions, you will need to check that those work first. And I think that's what one of the comments says there. Someone called Sonner has said there are icon V issues with Alpine, be careful. Yes, this is an extension problem between glibc and muscle C. So you do need to check compatibility with extensions, but really, really good way to save space and keep those images lean. The other reason you want lean images is when you are deploying to production, the smaller your image, the faster you deploy. If you're doing continuous delivery multiple times per day, this is bytes over the wire. Depending on your cloud infrastructure costs, you could be playing ingress and egress. Depends where your images live. There's all of these different things that you really need to work out. Okay, another thing we're going to be taking a look at today that always trips people up. Do not have multiple Docker files within your project. The chances are you can get away with one single Docker file. Taking advantage of, it's not particularly new, it has been around for about 2 years now, but multi-stage builds, the ability to, within a Docker file, use different layers to pull in the tooling that we need for each step within our build pipeline. Why is this important? Well, because our PHP applications aren't just server-side rendered anymore. We do have asset compilation with Node, and that needs different tools. Now, you could go down the route of just doing a Docker file and bundling everything together as a huge big base image at 4 gig, but there are better ways to do that. And we're going to take a look at the build cache today. This is the one thing that I always spend the most amount of time talking to people about at conferences, back when that was a thing. But tweaking your build or your Docker file to leverage that build cache is going to get your build times from upwards of an hour, 40 minutes, 30 minutes, 20 minutes, down to seconds, if not just a few minutes. And it could be as simple as just copying your composer.json before doing anything else, so that we don't have to do composer install every single time we build our image. And the golden rule of containers is do not log to files. Those files will be lost. It will be very difficult to get those container logs centralized. What Docker does and Docker provides is a really good log collection mechanism with a pluggable backend driver that supports syslog, FluentBit, FluentD, Graylog, Elasticsearch, Logstash. All of these different tools are supported by a few, 4 or 5 main protocols that Docker all supports. And the only thing you need to do to take advantage of that is to tell your PHP runtime to log the standard out. So vitally important. And I stopped calling this a tip a while ago and now just make it a mandatory requirement, right? We do reduce the attack surface of our applications in production drastically by using containers. But let's not leave any attack surface to those bad actors. You can run your containers with -- read only, and that will restrict any writes to the container image itself. You can, however, provide volume mounts for uploads if you're working on an application that does accept uploads. So but it will secure the rest of your system. What most bad actors do when they're trying to find that attack vector is use their upload capabilities to then write to other parts of the system. And with one simple flag, you completely remove that. Okay, so I do not know if this video is going to work, but I'm going to give it a go. It's not important if it doesn't. We can always just kind of cover it. But it's just to set a little bit of context. Over the last month, I've been doing a lot of live streaming on building a Docker Compose development environment and Kubernetes production environment for Laravel applications. There's over 9 hours of this content on YouTube, and I've just kind of compressed it down into 3 minutes to show you some of what Kieran and I have been working on. If you know Kieran McNulty, he's the maintainer of PHP Spec, and he volunteers his time just to join me and make it a little bit more entertaining than me banging my head off of Docker Compose for 9 hours. So I will hit play. If there is no audio, that's okay. Just let me know. I'll hit stop and we'll move on to the demo and take a look at a Laravel application. Okay, well, that would have been nice if it worked, unfortunately. So I just used this 3 minutes to talk about one of the major problems that we had while building out the Laravel tooling. The video is available on YouTube. I will post a link into the chat and you can watch it in your own time. Of course, there's a link at the end to all of the PHP sessions that we did to get the Laravel stuff to work. So let's just take a look at the Laravel. Whoa. See, I'm quite new to this Mac world. I've been a Linux user for so long, but my new office gave me a Mac. That idea. All right. So let me pull up my chat window again. There we go. So you should all be looking at VS Code now. This is the Ping CRM application. It's a CRM. It was built to show off Inertia.js, which I think is the JavaScript framework that it uses. And I used this as a sample Laravel application that we could just live stream, right? How do we take this non-container, non-productionized application and provide all of the tools that we need to go from nothing to production? So we're going to start with the Docker Compose file. Excuse me. Okay, so what you'll see first, we have the version 2.4, right? I'm very, very specific in that this is the only version you really want to be using for development. I know there are newer ones, and it feels like a bit of a backward step, but you will definitely thank me. So just trust me and go with it. We have the ability within our Docker Compose file to specify some volumes. Now, these volumes are being used as a cache. So they will live for as long as I allow them to within this Docker Compose project. Which means when I do the npm install for all of the front-end compilation and assets and translation stuff, I only ever really need to do that once. We persist the public directory because this ping CRM then stores the transpiled assets, the minified JavaScript and CSS, etc., into another volume. And I don't want that on my host. I try not to pollute my host with anything that doesn't have to be there. This also substantially helps the performance with running this application on a Mac, which does have a small hypervisor layer for the containers. But remember, we're not talking about that today. And then our database. We don't want to have to, migrate and seed our database every time we spin up our application. We may only wish to do that a handful of times or whenever we explicitly tell it to do that. So by using a volume, we can persist that state as well. Now, because, excuse me, I wanted this to be as production-like as possible, I have gone to the effort to make this work with Nginx serving some stuff, FPM serving other stuff, Node running in the middle, and our database. So this, while I would never use this compose file to deploy to production, all of the same calls, all of the same communication between Nginx, FPM, etc., all exist. So it's as close as we're going to get. Plus, by using the same base images that we use to build our production image, we still have that parity that we want. It's really, really important. So here, Nginx, we're just saying run the Nginx image. You're mounting in the public volume. That's where we're going to serve our minified and compiled assets from the node runtime. We're also mounting in our own Nginx configuration, which I've just stored here as vhost. Now, there's something really important in this file that I'll come back to in a second, but the number one question I get all the time is with regards to how do I make Nginx and FPM work together? Right? Should I put FPM and Nginx in the same container image? No. That is not the advice we should be giving to people. Containers should only ever run one process. And Nginx actually has the configuration language that allows us to do that. So if you have seen bits of this talk before, I have given this talk a number of times. I may have recommended doing something with volumes from. Well, not bad advice. There was a much simpler solution, which we're going to look at. With regards to ports, I'm just saying expose us in port 8000. It just makes the demo a bit easier and I don't need to open up the random port. And then this is the magical syntax. This is why I am clinging on to version 2.4 so much. Right? I have a depends on syntax here that actually allows me to specify the condition of the container as part of the dependency. So what I'm saying is Nginx is going to wait until PHP has started. And Node, and Nginx is going to wait until Node has started. Now, I'm not actually using a healthy thing here, but it is available. And we do have an example of that further down, so I'll get to it. Okay, that's the Nginx side. So with regards to the Node side, we're just saying using Node 10, and I'm overriding the entry point and the command this time. So I'm saying that I want to use a make target, and I've created a target inside my make file called node assets, which just runs the command that I need to build those assets for the development environment. We then expose this on a port 2. The reason I'm exposing node on this port is because in one of the videos, we decided to get, Laravel has something called hot module reloading. So you can actually get updates on the front end of your application without reloading the page. And I was determined to get that to work. The good news is it works. So we expose that port so that the front end application on the client side, the JavaScript client side, can speak to that server over a WebSocket and get those updates in real time without refreshing the page. Now, the volume information here is quite vast and extensive. You know, we do need to make sure that the node modules are available to node runtime. We need the public directory so that we can actually write the files to that directory once they're minified. We need our make file because we're using the target for the entry point and command. This one, artisan file, should not be needed. But unfortunately, Laravel Mix, and the video has a little bit on this, the highlighty video, I guess. The Laravel Mix fails if artisan isn't there. It actually uses the existence and location of artisan to decide where to write the minified and compiled JavaScript assets. And that was infuriating to debug. So it's there. I've saved you that hassle. We also need to mount the resources. So this is our JavaScript files and our view templates. We need to mount the package.json. Something else that was in the highlighted video was I am very opinionated about the existence of a lock file with container-based or container-native development and the production environments. You don't need a lock file anymore. However, this application and this JavaScript setup does use shrink wrap, which fails if the lock file doesn't exist. So that's a battle for another day. We also need the Webpack and Mix configuration and the Tailwind configuration. So this is just everything that the Node and JavaScript runtime needs to compile those assets. Okay, and if you're wondering, again, it's all in the videos. If you really want to sit and watch it for 9 hours, they're quite funny at times. This was a really painful try, loop, fail, try, loop, fail to get this to work. Trying to work out what is needed for all the asset compilation. Not something that works first time on local, but the minute we've got these very specific mounts into the container, things change. Now, I could have just mounted everything, but then we don't have any documentation. And this Docker Compose file could be considered documentation to the point of I'm now telling anyone who reads this what they need for these commands to work. what all the components are, what can be taken away, what can be removed, what can be extracted to another repository eventually, or something like that. So it's important to go through that process. Okay, now PHP. So here is where things get a little bit different from what we've seen so far. We're building our own image now, and we're using multi-layer images. So I'll pull that up in a second. We are mounting everything into the PHP just because we hadn't got around to only mounting certain things up, but I do intend to do more videos where I go through that process. Because Laravel is configured through environment variables, there are a few. We're using env file so that they can be kept separately and used in other environments if needed. And then we have a condition service healthy dependency. Why is this important? Well, our PHP application is actually going to fail if the database isn't accepting connections when we try to run the migrate or the seeds or anything like that. So we can just bake that into the dependency graph, right? We specify a health check on MariaDB, and that means that Docker Compose will wait until MariaDB is healthy, depending on how you configure your health check. And you'll see that I've taken a few liberties with that. And then our PHP application will come up afterwards. Here is the MySQL or MariaDB configuration. My health check is using a cool bash trick, if you're not familiar with it. Bash provides a kind of virtualized TCP and UDP stack, although the UDP one does nothing. The TCP one, though, does allow you to echo to dev/TCP/hostname/port, and it will actually try to open a connection to that IP address, that hostname on that port, and if it succeeds, then we consider it healthy. Fortunately for us, MariaDB only accepts connections when you can actually query or send commands to the database. This health check actually works really well. And we can specify, just keep trying every 1 second until it comes up. We're persisting our database, which is why we have our name and volume there for that. And then MariaDB and MySQL both require you to configure authentication. It does not work without authentication, without a special flag, but it's just better to specify the MySQL user, password, and database. The reason the MariaDB image uses MySQL as the environment variables is it is a drop-in replacement for the MySQL image. So really, really cool. So if you are using MySQL and you want to de-oracleize your own setup, you can drop in MariaDB, just works. Okay. So the things that we're going to cover now are the .env file. Now, this is pretty much just the one that comes with Laravel. You just tweak it to what you need. It comes with a sample file. You can modify it for dev. And then all of your other environments provide their own version of this. So you can see I'm just specifying the same information here. And then this is it. So they do get quite verbose. There is a lot of environments, a lot of configuration available to us. But if you're working with Laravel, you're probably quite familiar with that. Now, let's take a look at our Docker file. Now, this one is quite complicated. Like I said, this was me aiming for a pretty production-ready configuration. So the first thing I always like to do is configure a base layer. Why is that important? Well, it's all too common for people to add multiple layers, specifying PHP every single time. You can just have this empty base statement at the top and then use base throughout the rest of the Docker file. So it means that when I do want to upgrade to PHP 8, if you're feeling brave, you only have to change it in one location and rebuild the image and see if it works. In my base layer, I'm going to configure all of the dependencies that I have at an extension level and a system level. So that means I'm going to install all of the PHP extensions that I required and any dependencies that they have on the operating system. So for me to make PDO MySQL available with exif and GD, I just need access to Git, zip, libpng, etc. So in just 2 statements, again, this idea that the Docker file can provide documentation for building other environments is right there. I know exactly and explicitly what is required for this application to run on a machine. Then I do something different. In order to make the shell pattern work, which I'm going to show you in a moment, actually using it rather than hypothetically, I provide a dev layer. So you can see I have another from statement from base as dev. This is where I will provide any tooling I need for my development environment to be interactive and to work. Now, this node stuff isn't needed anymore, but I just hadn't removed it. In a dev environment, I may just wish to install Vim if I want to do something inside of the container quickly without dropping back out to VS Code or JetBrains or whatever. Something that you will need is Composer. The PHP official images do not ship with Composer by default. However, there's this really cool trick you can do where you can do a copy and specify another Docker image. Here, I can say from Composer 2, copy the Composer binary into this dev environment. And that just means that when I run my make D shell, it puts me inside of a Linux system, which has Composer and Vim available. And I can add whatever dev tooling I want to this layer, and it will never come or be shipped to the production layer. Okay, now we use a couple more layers for various purposes. This is the one that I use with Composer to do the dependency installation during my CI process. So you can see I'm also copying Composer, and I'm trying to prevent my build cache from being invalidated by copying the composer.json first. I can then run Composer install. Now, by default, Laravel applications, from what I've seen, do enable some weird scripts and optimizing the autoloader by default. So you do explicitly have to disable that. The reason why, our PHP code is not in this image yet. We've only mounted the composer.json. We use this command, it installs all of our composer dependencies. And because our build context, and by build context, I mean what we've copied into the container is only the composer.json, these two lines will always be cached unless we change the composer.json. And we copy in everything else. We copy in all of the other code. We run composer install again, so we can trigger the scripts and the autoloader. And then we can optimize that autoloader as well. Then when it comes to distributing, so that's our CI stage. That's where we build our production image, at least the dependency aspect of it. Then we can specify an FPM image. So we actually have multiple artifacts from this application. And what I'm going to do here is just say copy from my build layer and grab all of the code. So that'll be my vendor directory with my PHP applications and the autoloader that we generated previously. And the reason that we separate this out in a step is so that we can also use the build FPM, the CI layer, to run tests. And Docker with BuildKit enabled will actually run these two layers in parallel, which means we're running our make test at the same time as we're building our production. We're running our make test just after we build our production image. And then we have our node image here, where we are running our CI and run production. So this is just how we compile our node applications. And then finally, we have an Nginx one where we're copying in our production virtual host configuration and copying our assets from the node build layer. Now, I know that's a lot, and I probably stumbled a little bit there, but there's just a lot going on. And what's important is really leverage the from statements multiple times, really compartmentalize each step of the build thing. And this will make more sense of why I'm going through these hoops as I run it. I'm also aware that I'm running out of time. So let's continue. Okay, so what does this look like in practice? Well, the first thing we want to do is run make D shell. Now, like any good demo, I'm going to just show you there's nothing running, right? This DC is just an alias for Docker Compose. I can run PS, which lists the processes. There are no containers running in this project. When I run make D shell, you'll see that we are spinning up Nginx. We're creating a network. We create all the volumes. MariaDB is created first because we have so many health checks or dependencies on that layer. And then eventually, we end up inside of a container. Now, there was something a little bit magic here, and our D shell also does write this address and port number to a file in public hot. This is how we enable the hot module reload in Laravel. We have to configure it and tell it where the port number and a host is for the node runtime. If I drop down to my host and run DCPS, what we're going to see is MariaDB is healthy because it has a health check. We know that it's healthy. And then we have our Nginx process. We have a node process, which is actually running an npm run watch. So it's going to watch all of the assets and wait for changes. We have a PHP runtime running FPM. So the PHP runtime is actually serving FPM serving files. And then we have our interactive D shell. This is the terminal that we are in here, which allows me to pretend this was me developing natively. And what I mean by that is I can run composer install like I would as if I was developing locally. Yep, it should be fast because I have kept my cache from a previous run. Something else I can run is I can run my test as well. So if I was, doing test-driven development, this D shell should just feel very native, nothing wrong. Okay, now I need a terminal window. Let me pop one over here. All right, so I should be able to, assuming I've not messed anything up. Oh, wait, the wrong port number. That's my NPM port. Dun, dun, dun. It's waiting for polyfill.io. Normally it's much faster than this. I'll give it a few more seconds. I'm now at the stage where I wonder, should I just open a new tab? Should I hit refresh? Am I being impatient? All the usual things. Yeah, so I mean, I'll leave that for a second and I'll tackle a comment there. Johan has said that Docker on Mac is often slow. Yes, the problem there is that hypervisor layer, because Docker containers, Linux containers, do not run on a Mac natively. So there's actually a hyperkit VM, which is based on Xhive, which Docker behind the scenes is actually syncing those files, and it can really be painfully slow. I don't know if I'm just eating up all my bandwidth with the stream and it's failing to get external resources, but it definitely never takes this long normally. So I'm assuming something is broken. Let me try, because I don't normally use Chrome, and there was a hack for the module reloading that I wonder if I'm running into a problem with that. No, something's just broken. That's unfortunate. Okay. I'm not going to try and fix that in a couple of minutes, so let's just close this. Assuming the demo gods are on my side, we would have seen the login page for Ping CRM load. I would have been able to modify the JavaScript assets, which would have been live reloaded for us. Now, I will do my best to show you that so that you can at least have some level of confidence that this works. I wonder if those assets just hadn't compiled yet, and that was the problem. But it does seem to have compiled now. So what I'm going to do is modify one of those assets, and then we should see Node here reload that live for us. So if I open resources, JavaScript, pages, dashboard, this is our view file for the dashboard, and I can say, please load. When I save that, we immediately see that Node runtime here has already detected that change, recompiled it, and it's quite happy. So and on my other screen, it's still just saying waiting. All right. So that's how it should work. I'm not sure what the problem is, and I think I covered pretty much everything I wanted to cover. So multi-layer Docker files are really important. They allow us to segregate and separate the different dependency graphs that we have, from Node.js to PHP, etc. Each of those have their own specific runtimes. We can use Docker Compose to describe all the services that we need, and provide a cohesive development environment with an interactive terminal that allows us to feel like we're developing natively on the host. And so last warning, last section, a very quick warning. Like, I know a lot of people are moving from monolithic applications to microservice dependencies. And while on the surface, using Docker Compose for that may look like a good solution, you really got to be careful. Next. So yeah, Docker Compose may look like a good solution, but unfortunately, adding on millions and millions of microservices is just going to overload Docker Compose. It is not going to work. If you're adopting microservices and using a container native workflow, the microservices need to be independently developed and worked on in isolation rather than a part of the big system. If you need to work on microservices as a whole, then we need to travel back through time again. We need shared and common development environments with Kubernetes or with Nomad or with whatever to provide a way to do that. So what I would suggest is it's unfortunate that the spinner was loading on that page. Maybe it's Docker for Mac, maybe it's when bandwidth, I'm not really sure. The 3 sessions focused on building out this development environment are all on YouTube. You can find those videos at rawcode.live/php. There's also other sessions with Derek of XDebug where we look at profiling applications and really trying to produce really helpful content for PHP developers. And I hope you find it useful. All of the codes from today is available on gitlab.com/rawcode/php-examples. So hopefully it works when you spin it up. You should be able to run make shell and it should just work. I'm happy to take any questions if I have enough time. Thank you for your attention. And it was a pleasure speaking with you all.
Okay, David, thank you very much. I think it was really useful presentation, and I learned myself quite a few things, although I'm doing a lot with Docker and so on. Okay, in the audience, in the chats, I would like to call for some questions, if you have any.
Je moet dan eventjes de Q&A aanschakelen.
Waar is dat nu weer? Oh.
Dat is daar links. De Q&A die je luidspreker, geloof ik dat was. Ja. Dan kunnen mensen vragen stellen en dan kan je...
Ja. No. Any questions, guys, in the audience? Now we enabled Q&A mode, which means that if you press on the question mark, then your question will be shown on the screen as well for everybody.
We have a question.
Show question lists.
Then show.
Yeah, click that up.
So the question is, if you're new to Docker, what starting point would you suggest to learn more about it? Yeah, it's a really good question. I mean, there's a lot to take in with Docker. You know, it's trial and error a lot, but there is a really great website that I would just pull up now. And I don't know if my screen's actually being shared, so I won't do that. Katacoda.com, and that's with a K, so Kata. Coda, CODA.com. Katacoda is an interactive development environment with scenario-based learning. So you can go onto there and you can actually learn about most container tools and cloud-native technologies. You just say, I want to learn Kubernetes. I want to learn Docker. I want to learn core DNS. I want to learn Envoy proxy. There are scenarios for all of these tools where you just click on it. It loads a cloud environment where you can get like this little terminal in your browser and it says, hey, right, to run Docker, you run this command, and it gives you the commands and you follow it through. Very interactive, very great learning experience. I recommend that to everybody. It's one of my favorite resources for learning all of these technologies, not just Docker. Check it out.
Yeah. Thank you very much for your answer here. We're learning every day something more. Any more questions from the public? Okay. There's another one from Michelangelo.
Okay, so if you have Nginx in the FPM where you have your app resources in var www.html, how can you publish them into a known volume? Yes. So I guess, yeah, my screen's not shared. So you can define a common volume, like I did at the top of the Docker Compose file, which creates a named volume within the Docker Compose subsystem. You can then use that volume in your PHP FPM and inside of your Nginx. You can also do this through the Docker file. So the Docker file has a syntax called volume as well. And that just means that anything put into that directory in a container can be consumed by other containers. And there is a flag for that on the Docker runtime, the command line runtime, -- volumes from, which will allow Nginx to consume the volumes from FPM if you wish to go that route. The one thing actually we didn't cover when I showed the Nginx configuration is that it's actually rare that you need to share that volume anymore. Nginx has a try files directive, which will actually tell it if the PHP file doesn't exist within the host, proxy the request anyway to FPM, which is what that setup is now doing on the file. So if you go to the GitLab repository /rawcode/PHP examples, look at the Nginx configuration for this example. Look at the try files directive. You don't need the PHP files to exist in Nginx anymore. Nginx can just deliver the static assets, which is really, really helpful. It simplifies a lot of the operational burden of FPM and Nginx running in tandem.
Okay, thank you very much. Any more questions? I don't see anybody typing. Mike, do you see anybody? No.
No questions. Not even on the other channel. So.
Okay.
Well, David, thank you very much.
Yeah, you hear Michelangelo. Thank you very much once more. I will look forward to have you in the future also on more talks for PHP Benelux. So thank you very much once more. Thanks.
Yeah, thank you for having me. It was a pleasure.
Okay.
Bye.
Oh, shit. Okay. And now
the break, 10 minutes.
All right. We'll now have a break of around 5 minutes, 5-10 minutes. So at latest 8:15, we'll continue with the second talk for tonight by Mark Baker. See you soon. Cube. Mhm.
Hey, Mark. You should be now having presenter options. You will see red dots underneath your screen, or in the square on top, somewhere around. Yeah.
There you are.
I'm looking for him. I'm looking for him. Red dots.
Yeah, well, you've managed to push 2 from 3. So you have now audio, you have video, and there's one red dot next to it, which is the share screen.
No slides yet. Hang on.
Oh, okay.
Okay. We have slides.
Mark, do you have the telly on?
No, it's just me here.
Okay.
Find my slides. Hang on. Okay. No. Okay. Can you see slides now?
Not
No.
yet.
Because you're not sharing your screen or so.
Can you click on it? Oh, can you click? Screen sharing allow. Yeah. No. Screen sharing. Yeah. No.
Huh?
Click it. Yeah. Can you now click the screen share?
Screen share should be shared.
But it's not on here. Aha. Yes, where?
Yes. SPL iterators.
Okay, so I guess we are getting ready almost for our second talk.
Full screen mode.
Yeah.
Yeah, it's fine. It looks fine here. So if we can have a view of the speaker.
Yeah, you're a little bit off. Slides work great. There you go. Awesome. All thumbs up.
Okay, so that should be everything shared. Can you hear me okay?
Yes, sounds is very good. So at least for us. Okay, then shall we officially start? So welcome back for our second talk, which will be done by Mark Baker. And I would just ask you, Mark, just go.
Sorry,
You can start, Mark.
I keep hearing myself repeated in the background.
Okay, I will switch off audio here. It will be soon be gone.
Ooh. I keep getting an echo of things I said about 5 minutes ago. Okay, thanks. So I should be on air. I hope I'm on air and broadcasting. If not, I'm sure someone will let me know. Oof. There's technical problems that I'm hearing, but I'll try and go ahead.
Yes, please.
We hear you loud and clear.
Everything looks okay from this side.
Okay, I'm going to talk tonight an introduction to SPL Iterate. Talk to you tonight about SPL iterators and about how they can improve your code, make it more readable, in some cases more performant. SPL is a part of PHP that was introduced way back in the early days of 5.3, I believe it became part of core PHP, but still is not often used in people's PHP code, and it could be a real benefit to you. In part, that might be because of the descriptions in the documentation on the SPL iterators. It's rather complex. There's a massive, difficult to understand iterator names, and the documentation itself can be still a bit sparse and a bit non-committal about how they can be used and how easy it is to actually use them. I'm going to start with some basics. What is an iterator? I did a Wikipedia checkup. That doesn't particularly help. An iterator is an object that enables a programmer to traverse a container, particularly lists. It doesn't say a great deal about what it actually does for you. What is traversing? Well, traversing is defined as a behavioral design pattern in the Gang of Four, the iterator pattern. And it's something you're all familiar with because I'm pretty sure every PHP developer has iterated over arrays before. Something like this. For each loop, simply iterates over the array, gives you a result. In this case, simply echoing the key and the value from the array. Now, an iterator is doing exactly the same thing. One of the basic SPL iterators is an array iterator. You just give it your array, and you can for each over the iterator this time, the array iterator. We get exactly the same result back. Yeah. Why would we want to wrap an extra level of complexity? Well, an iterator is doing a few things under the hood. The iterator interface defines a number of public methods: current and key, next, rewind, and valid. When we actually do that for each loop, it's executing a number of those functions or those methods. We could write it out longhand like this. So we rewind the iterator to the beginning, execute a while loop, testing whether there's a valid value from the iterator. We retrieve the key and the current value, we echo them, and move on to the next. And when we use a for each loop to iterate over an iterator, it does that in the background. gives us the same result if we execute it longhand. Now, I like living here in the Netherlands. One of the places I really want to go to is the Efteling, and the Efteling has this wonderful roller coaster called the Python. So I thought squeezing Python into a PHP talk was kind of cheeky, but hopefully we're going to go through a few loops here. But before you get on the roller coaster, you generally have to queue for a little while. So I'm going to start off quickly, but going through the basic iterable tree. Looks a bit complicated. All those are type interval. Iterable is your absolute base and covers everything that is either an array or a traversable. Your for each will run over any iterable, whether it's an array, whether it's traversable, whether it's an iterator or an iterator aggregate, or over a generator. But there are a number of differences between these things. Not all iterables are equal. You can count the elements in an array, but you can't necessarily count the elements in an iterator. Sometimes you can, sometimes you can't. It depends, and I'll get onto that in a little bit as we loop through. You can access the elements of an array by their index. Can you do the same for an iterator? Sometimes you can, sometimes you can't. None of those make it iterable, though. Being able to count the elements in an iterator isn't what makes it an iterator. Being able to traverse it is what makes it an iterator. You can rewind an iterator, but you can't rewind a generator, or can you? Well, something else we'll come to later. There's a number of iterator functions, such as iterator to array or iterator count, which work on iterators, which won't work on arrays. They will also work on iterator aggregates, despite their name. So, what is iterable? Quoting from the PHP docs, it's a pseudo type. You can't have an iterable in your code, but you can have things that type into iterable. An array type hints as an iterable, traversable type hints, an iterator does. An array is actually an ordered map, again, purely from the PHP documentation. It's a fairly big quote. Another quote from the PHP documentation: the for each control structure exists specifically for arrays. No, it doesn't. It exists specifically for iterables. Don't forget that. For each will always work with either an array or a traversable of any kind. Traversable is a non-existent abstract base interface. Iterators and iterator aggregates both implement that. There are some caveats on that, because PHP has a number of internal built-in classes that implement traversable without actually being iterators or iterator aggregates. Examples of these, things that you do work with probably on a day-to-day basis: PDO statement is traversable. Date periods are, for those that like the PHP's datetime interface and all its related date interval, date period, etc. You can iterate over a date period is traversable. And if you're working with XML, you've also got simple XML element, which is traversable. There are others, but those are the three main ones that I at least use on a regular basis. Iterator is an interface used for external iterators or objects that can be iterated themselves. PHP provides a number of these already as standard part of the SPL. Examples of those, the SPL iterators that I'm going to be talking about tonight. Also SPL data structures like heaps and doubly linked lists are iterable they implement the iterator interface.
Mark.
And for those of you who are looking at PHP 8, weak maps are also iterators. Generators, I hope some of you have worked with generators before now. They provide an easy way to create an iterator, but because it's easy and quick and clean to implement, they do have some limitations. For example, they're forward only, you can't rewind them. At least you can't rewind them once iteration has started. Finally, there's iterator aggregate in the tree. Horrible turn of phrase. Basically, it's something you can wrap anything iterable in to implement a for each loop using it. Okay, getting started on the actual roller coaster itself. Now that we've queued, we're seated, let's implement a couple of our own iterators just to see how straightforward it is to do so. The iterator interface, you have to implement 5 key methods: current, key, next, rewind, and valid. So let's look at iterating over a UTF-8 string. We'll create a class, implements iterator. I'm going to do a construct where we pass in a string and store the length of that string. Valid, we compare the length of the string with our current offset, which will start at 0. Rewind will reset the offset to 0. Current will simply give us the current character at the current offset. Key will give us the offset itself, and then next will increment the offset. So we pass our string into the constructor when we instantiate a new UTF-8 string iterator, and we can for each over it. All I'm going to do here is wrap each character in turn in square brackets. Very straightforward to implement. That is an easy one. Another example, a file line iterator. We'll pass in a file handle. We will open that file, and I'm going to add a distrct method here to close the file handling when we go out of scope. Otherwise, you can end up with a lot of handles lying about used if you're opening a lot of files. We'll start our line numbering at 1 because file line numbering generally does start with 1 rather than with 0. So current simply reads the file, trims off the trailing new line character, and returns that value. The file pointer itself will be adjusted automatically, as it would with any stream that we're working with. Key, we're going to return the current line number, and next, we're just going to increment each line number because the line numbering is something we have to keep track of here ourselves. Finally, rewind, fseek back to the beginning of the file and reset our line number. Valid, we're just checking for the end of file. And again with the code, we just instantiate our file line iterator, passing in a file name. Then we can for each over it, returning the line number and the content of the line itself and displaying it, and so on. So 5 methods to implement, any additional housekeeping that we might need, and we have 2 very simplistic iterators there that we've written ourselves. Okay. Moving on to ways we can use them within existing code. This is something I will often find in code, in businesses, in many companies that I've worked for in the past. We have a nice user repository and a method all. It could be a filtered method as well, where we pass in query arguments. But we build SQL statements, prepare it, execute it, implement a fetch all, and then array map that to return an array of user objects. You notice the type hint for the all method is simply array in this case, because that is exactly what we're returning. That's not much help when we're working with an IDE, so typically we have to implement a dot or add a dot block that says it's an array of user objects. Now, what we can do is return instead a user collection. We'll just pass our array into an array iterator, but we're creating a user collection here. So now we can type in return new user collection. That helps a little bit with our dot block, insofar as we know that we're getting a specific type of collection back. We've not done anything particularly fancy inside the user collection. It doesn't know what it's an iterable of. You would still need to implement or have the dot block in there to identify it to an IDE, but it gives us a slightly cleaner, more descriptive public interface for the all method. We know we're going to get a collection of users back, a user collection. Now, we can be a little bit cleverer. We can move our conversion to a user object into the current method. So we're overriding the current method of the array iterator, and we're specifically saying we get a user object back from it. That then will help with our type hinting. So we've got a new user collection. We're just passing the users in and letting the user collection, rather than the repository, handle our conversion to a user object. So we've now got a separation of concerns as well. Now, there are a few things I mentioned earlier. Is an array countable? Yes. Is an iterator countable? Depends. The one iterator that I've shown so far is the array iterator. That implements, well, it implements iterator through the seekable iterator interface object, but it also implements countable, array access, and serializable. So it gives us a lot more than a straightforward iterator would normally give us. Countable, must implement a method count. Well, yes, it does, and we can demonstrate this simply by doing a count on the list that we've got back, the collection that we've got back from wherever, from our database, from XML files, from an API call. In fact, we can do it using count, as demonstrated here, or we can do it using the count method for the user list. So we've got a slightly cleaner, it's one line less, but when we echo it out, we can just echo the result of calling the method count on the user collection. And it tells us. So an array iterator specifically implements countable. It implements array access as well, which is what allows us to access, modify, delete, retrieve, do exists on it, a specific offset within the array iterator. So we can ask for the third entry, the element at offset 2, PHP count from 0, exactly the same as an array. It implements serializable. We can serialize it to stash it in a Redis cache or something similar. Serializable simply has to implement two methods, serialize and unserialize, and we can serialize our user list here. That can be cached. Note that it is a user list object, not an array, but it still has all the appropriate data in to allow an unserialized to recreate that user list. Seekable iterator is probably the most interesting here. What does that mean? Seekable iterator adds one new public method, seek, to the iterator interface. What we can do is seek a particular offset and then while our way through and retrieve elements from offset 2. So in this case, it should just return user 3 and user 4. And indeed, that's what it does. However, it's not quite as nice as it might seem. We had to use the while here. If we do a seek and then a for each, remembering that the first thing that an iterator does when you for each over it is rewinds. It resets us to the beginning. So it's not quite as nice as using for each in this case. It would be nice if we had an indexed array, if we could access via the index, not simply the offset. No, we can't, unfortunately. And if you're running PHP 8 already, it's a fatal error, not simply a warning. With seek, you always have to use while, and you must always seek on the offset position. So not quite as clean or as easy to use as you might like. We'll have a look at getting around that limitation in a couple of minutes. The array iterator does also provide methods for sorting, usort, uasort, ksort, all the standard array methods for sorting have an equivalent method for sorting in the array iterator. It doesn't work with array functions, unfortunately. No iterator works directly with array functions. So there are still some limitations there. Okay, we're heading into our first loop now. This should be fun. Okay. SPL has this horrendous list of iterators. You probably can't even read them. There's so many of them. But I want to look at just a few of them tonight and the benefits that they can provide. Now, seek has limitations, but there is what's called a limit iterator. It's a little bit like array slice. We can pass it an offset, and we can pass it a length, which seek can't give us. And then we can for each over the iterator. And the other thing to note here is we can nest iterators. Our user list is an iterator, and we're nesting that. We're wrapping a limit iterator around it, saying, give me the items from offset 2 and just the first item. Would you excuse me just a moment? There's the result of that. Hi, Michelangelo. I feel I've got Michelangelo trying to get hold of me, but I'm not sure why.
Okay, Mark, here.
Sorry, Michelangelo, I'm getting too much.
Mark, we are hearing a chirping echo, and actually right now it looks to be better.
I can hear you at the moment, but I am getting too much feedback on the headphones.
Yeah, right now it's better. And actually right now it looks to be better.
Okay, let's try carrying on and see if the sound is any better. But I am getting too much feedback on the headphones. Okay, so limit iterator is basically an array slice on an iterator. Okay. Let's try carrying on. Okay. Okay, so limit iterator is basically an array slice on an iterator. Okay. Let's hope turning the volume down allows me to hear what I'm saying and doesn't give you any feedback. Let's carry on from where we are.
Yeah, that looks to be it. Yeah.
Okay, another interesting iterator is the infinite iterator. This will iterate through to the end of whatever we're iterating, then execute a rewind and carry on until we stop it. Now, we could use a count in the for each to tell us to stop when we've got 14 elements in. But one benefit of the limit iterator is we can wrap that around the infinite iterator, and that will tell it when to stop. So, working through the days of the week from the date for 2020-09-08, 8th of September, I believe, was a Tuesday. So the Tuesday should be our first entry. And this will give us 14 days. Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday, Monday, Tuesday, because we'll just keep rewinding until it has gone through 2 whole weeks, because we're stopping after 14 entries. Sure enough, that's what we get. Now, you may like to work weekends, but I don't. So I want to filter out my weekends. So I can wrap the whole thing again in a callback filter iterator, which tells it to ignore Saturdays and Sundays. Only return values using the PHP 8 arrow function, or the arrow function here, to return a Boolean, which tells us whether to include that day or not. And sure enough, we've not got weekends in there, so I don't have to work weekends looking ahead. one of the really useful things about iterators is this fact that we can wrap iterators inside other iterators, inside other iterators. So we've actually got 4 different iterators here. At the heart of it, we've got an array iterator of our weekday names. Nice simple list of 7 names of weekdays. We're wrapping that in an infinite iterator, so it will just keep on iterating that until it's told to stop. Rewinding at the end so that it will carry on again from the beginning. We're wrapping that in a limit iterator, which tells it to start iterating on the offset for the current day, Tuesday in this case, the 15th of September, and give us only 14 entries. And then we're wrapping that in a callback filter iterator, which tells it to filter out Saturdays and Sundays. And we can nest and nest and nest to our heart's content. And each just feeds its values back up to the next iterator in the tree, giving us a very useful way of working through a whole series of different types of filters, different types of queries generally against the underlying data. What we do have to watch out for is the order in which we do these. If we put our callback filter iterator for Saturday and Sunday inside the limit iterator, we would get 14 weekdays instead of 10 weekdays. Okay, filter iterator, how does that actually work? It has one additional method, which is the accept method. Accept returns a Boolean, but has a criteria that allows us to say whether to ignore or whether to accept this particular entry. So I've created another iterator here, an image file iterator, that extends filter iterator and implements that accept. We're passing into the constructor a file system iterator, which will just loop through every file in the file system in a specified path and return that. However, the accept narrows down exactly what we should and shouldn't accept. So I've got this particular one to say, just give me all GIFs, JPEGs, and PNG files that it finds. So the filter iterator, or should I say the file system iterator, returns a file object by default. So we can get the current file object, and we can use the file object get extension method and preg match that to see if it's an image file or not. There's one interesting thing, and it's not described particularly well in the documentation. GetInnerIterator current will always return the current object or current value of the inner iterator in our series of iterators, and we can access the methods on that, in this case the file object. However, it also, undocumented, makes that available as this. So we can simply get extension because we're working on the current file object here. So we can simplify the code slightly. To execute it, as simple as gives us a list of all the image files in a directory that has a lot of PHP files, text files, etc. What else can we do that's interesting? With any iterator this applies, we can also override the key method. In this case, return the extension of the file as the key for our iterator. There are a lot of PNG files in that. But let's look. We'll return the extension, or get the extension and display that. Should I say a lot of JPEG files rather than PNGs, but yeah. So one advantage that an iterator has here over an array is we can effectively have duplicate keys. We can use the keys for something interesting, even if there's going to be a duplication of data, a duplication of keys. Another problem when you're working with arrays, you're limited to keys that are integer or string values. Well, we're returning a string here, but what if I modified the key to return a date time object for the date when that file was last modified? For each over it again and apply formatting within my for each loop. Sure enough, that works. So iterator keys aren't limited to being unique and aren't limited to being integer or string. We can actually return value with the keys. One of my all-time favorite iterators is the multiple iterator. You might often see something like this in code. Assume that we're getting dates from user input, budget is coming from an Excel spreadsheet somewhere in the finance department, and expenditure comes from a database. So 3 things we can iterate over, but all coming from different data sources. And people will often try and match those up on the keys. Here, done as a for loop, looping through the keys for however many budget entries there are, or it can be done as a for each, which returns the keys for dates and then matches up against budget and expenditure. Yeah, it gives us the result we want to. But enter multiple iterator. Just applied a little something here to wrap our results that we want to loop over in arrays so that we've got iterators, or wrap array as iterator. And we instantiate multiple iterator, and I'm telling it to telling it with mitkeys a sock to give each of these iterators a name. First one will be our date, second one budget, third expenditure. So now we can loop over the combined iterable that we've created with the multiple iterator, display date values date by name, budget by name, and expenditure by name. They're the keys now for the array, or at least the iterable that we're returning each entry and date values for. If we want to be slightly more pedantic, we can use list syntax to assign them to variables. And there we are. Now, it's mitkeys a sock, which is what allows us to specify the names. The attach iterator method injects each iterator into the multiple iterator, but also allows the second argument of the name that we're going to use. So list will just work on the order that they're there, but we can specify by name and use extract. A lot of people don't like using extract at all. Extract is risky, you're always told that, you don't know where your data is coming from, so what are you extracting? Well, in this case, because we have specified the names, date, budget, and expenditure ourselves, we know exactly where those values are coming from, those variables that we're going to get. So extract is safe to use in this case. and it gives us exactly the result. The difference here is it's a lot more readable than for I equals 0, I less than count, dates, etc. We're being very, very explicit in our naming, which gives us improved readability for using the multiple iterator. A recent example that I came across was someone basically doing this. This is used with permission. It was a question raised on the PHP user groups help section, allocating an advance to a number of cars. This was basically the code that was being used. So we're setting the advance for each car in turn, but we're having to retrieve the index I, the key for that car, and get the allocation based on that key. For readability, it's more lines of code, but we're setting our names here, car and allocate and advance. So the allocation will be the advance for that car. And we have something that is a lot more intuitive in a lot more ways. We're not referencing index offset 0. We're accessing advance for the specific advance. Mentioned briefly inner and outer iterators. An inner iterator is something you can iterate over. It implements an iterator or extends an iterator. There's a few examples we've used. Array iterator iterates over the array. Seekable iterator gives us that with an offset, seekable offset. File system iterator iterates over the file system. It's iterating over something tangible. Outer iterators are the wrapper iterators. Now, any iterator can be a wrapper iterator, generally speaking, unless it's purely an inner iterator. But it's the outer iterators that we wrap around our inner iterators. So we've seen limit iterator, infinite iterator, filter iterator, and callback filter iterator so far. They can't be executed or instantiated on their own. They have to be a wrapper for something, for another iterator. The third type of iterators, which I'm going to gloss over here, are the recursive iterators. They allow you to look at hierarchical data structures, such as nested arrays rather than simple arrays, or nested objects if you're using array access. File system iterator iterates over a directory, but if you're using the recursive variant of that, you can drill down into the individual directories and folders of your file system. Looping back, I do like looping back in this particular talk. Back to our user repository. We're implementing a user collection. This is where we'd left it. And we're doing the basic mapping here in the repository. But if you're working with several thousand users that you're retrieving, there's memory issues when you work that with PHP. It has to allocate the memory for that array. It has to execute the toArray method or fromArray method of the user object to convert each one as necessary. And it does that for every one of those 1,000 or 10,000 or however many you're retrieving, all at the point of executing the statement, even if for whatever reason you're going to discard some of those rather than display them all. Generators are a very good way of simplifying that memory usage. So you're only actually working with one object, one user in memory at a time. So this would be a simple example of converting that previous query that does the fetch all to instead give you an iterator, a generator in this case, that will yield the users one at a time as you for each over them. But we can take this a few steps further. That's how we would have to type int it for our IDE, but this is where we get to iterator aggregate, which becomes a whole lot more fun. It implements just one single method, getIterator, that returns a traversable of some description, such as a generator. So what we can do is modify our user collection so that instead of injecting everything into an array iterator, we implement an iterator aggregate. We pass the PDO statement in as the constructor before we've executed it, but after it's been prepared. And the get iterator, we're going to execute that statement and then loop over it. That gives us a traversable. That gives us our iterator. And it allows us to use the yield statement here. Why do we do it like this? Why do we pass the statement in? Well, that's how we would execute it in our code. We return a user collection, but unlike a normal generator, we for each over it once, we can't rewind. Using this method actually does allow us to rewind it, or make it seem as if we rewind it, because when it does its rewind, it will re-execute the query and start yielding again from the very first record in that set. There may be slight disparities if new user records have been added in the interim, but it does give us a method of pseudo rewinding a generator. Looping back to something else again, looping back to our days of the week, I'm a big fan of fluent interfaces. Here we've got nesting, 4 levels of nesting. So what did I do? I decided I wanted to use a fluent interface instead. I came up with something like this, where we inject the inner iterator into the constructor of an iterator aggregate. We'll call that fluent nested iterator. We then have a with method as part of our aggregator, and all that does is it does the nesting for us. It creates a new iterator of the appropriate type, injecting our original iterator in, together with any additional arguments that we pass to the with. For example, for our offset iterator. And then get iterator will always return the top iterator in the tree, but that has everything nested within it now. So within our code, it would look more like that. Personally, I find that's a whole lot easier to read. Gives us exactly the results we expect. There's a couple of array functions that don't work with traversables that are extremely useful. And I was working with large volume data to keep track of where my cats were. From left to right, we have Osiris, we have Penny, we have Roman, and we have Osiris, Lexi, Roman, and Penny with an elephant. I've got to squeeze an elephant in here somewhere. And I was using generators to keep the volumes of data low, but I wanted to be able to use map, filter, reduce, the array functions, and they didn't work. not with traversables. That's Roman's GPX collar that logged all the data that I worked with. So what I did is I implemented variants of array filter that will work with an iterable. I will work with an array or with an iterator. That was the filter code. I'm just providing a callback for it. If the callback matches, we yield, otherwise we don't. But it just loops over the iterator. PHP 5. Whatever introduced the callback on key, on value, or on both. I implemented that using a simple switch in there because I like returning date time objects as my key. So the code for returning one of the cat's movements between a set of date and times was implemented using my filter, using exactly the same syntax as I'd used for array filter, but which I can now iterate over even though it's a generator. And I know exactly where Roman was between those times. That was rather a while back. Of course, there are alternatives. We could use a callback filter iterator if we know we're working with iterators. But my little piece of code, my little function will work with both iterators and arrays, whereas callback filter iterator will only work with iterators, so we need to wrap any arrays we might want in an array iterator to use it. Map. One thing that the data didn't give me was the distance between the different points. So I created a map function, the equivalent of array map. I can then set a calculator which adds a distance between the previous point and the current point for each over that. And now I've got the distance from the previous point each time. Finally, yes, there is a function that I could have used to do that. Iterator apply is the equivalent of array map, but only works with iterators, whereas array map only works with arrays. My function is the equivalent of both. As the syntax for the iterator apply is exactly the same as the syntax for array map, except that it only accepts iterator, only accepts a traversable, not an iterable. Reduce, well, reduce everything to one value. In this case, I'm using the distance calculator to get me the distance between each point, and then have a callback which basically just gives me a running total of distance up to that point from the start point. And Roman didn't walk very far that day. He could get as much as 20 kilometers a day. Other array functions, there are iterator equivalents, iterator count. It has its risks. Never use it on an infinite iterator. You'll run out of PHP runtime before it finishes the count. You've also got iterator to array if you ever need to convert iterators to arrays. But to be honest, I think when you start using iterators, you don't want to go back to using arrays again. So, signing off into the sunset, we've finished our roller coaster ride. I hope you've enjoyed the show, hope you've enjoyed the talk. A little bit of reading material for you to work with if you want to discover anything more. I've written a number of blog posts on working with iterators in the past, including my code for cat herding and working with the GPX data from Roman, etc. And there's also a blog post there on working with multiple iterator. As I say, it's probably my all-time favorite iterators. If you want book reading, there's 2 good books on the subject. One of them by Cal Evans, Iterating PHP Iterators, and you also have Josh Tyson's Mastering the SPL Library, which covers a lot more than just iterators, but does have a very good section on iterators as well. Now, I've been without sound since it started getting to me, the feedback on this, but I hope you've enjoyed the talk, and I'm going back to sound so I can hopefully hear any questions you might have.
Okay. Thank you very much, Mark. Very nice presentation. So to our audience, if you have questions, you can post them in the chat. I will activate the Q&A mode again. So if you click on the question mark, then the question can be displayed on the screen here. Okay. Thank you very much, Mark. Very nice presentation. So to our audience, if you have questions, you can post them in the chat. I will activate the Q&A mode again. Getting up here.
A lot of typing.
Presentational, recommend the slides. Yeah. Nice, these comments.
Well, Mark, it seems like no questions are coming in.
Okay, I hope the sound was rather better for the second half of that talk.
Yes, it was.
Yeah.
We should actually put it also in some kind of instructions for our upcoming speakers, some basic guidelines. We're learning, of course. This is just our second meetup that we're doing for PHPBenelux. I'm wondering if there are still questions coming, or
there's one from Paul. A little bit up in the chat. I don't know if it's a question or not. On top of that,
some more comments. I think.
Oh, okay. It's just a comment.
Yeah. Okay. Okay. Well then, looks that there are no questions for you, Mark. So for everybody, it was very clear and very interesting. So that's very, very, very good. So then, thank you once more, Mark, for your very nice presentation.
Okay. Thank you for having me.
There is still a question coming up, apparently, from Paul Delaire.
Hang on.
Hang on, yeah. I can also. So, Mark, you see it in the chat? Would you be okay to review the library?
Publish.
Yes, I will take a closer look at it tomorrow or over the weekend and give him some feedback.
All right. He's happy.
Very nice.
Well, Mark, congratulations. Well done.
Yeah. Thank you. So I will make you an attendee again. And then Mike, can you come online with the info account, or shall I promote you?
Just promote me.
Make presenter. So, I will. So yes, one important thing for us, if you please would make the effort to rate the speakers on Joined In. It's also very useful for us for planning also future talks and maybe some bigger events that we are dreaming of. But now it is raffle time, and for the raffles, Michelangelo will take over now, because it's basically all from him. And Into IT, our sponsor for tonight.
Yeah, just give me a second.
Yes, I give you a second.
All right. Hey.
Yes.
Look at this.
A very old laptop still works. Okay, raffle time. Let me see if I can share my screen. And I need to have my Chrome. There you go. Everyone is seeing this? All right. I learned from the other time that I should not take the list of Meetup. I should take the list from the Click meeting. So everyone that is here is accounted for also in this list. So what I'm going to do is I'm going to click, and we probably will have a winner very shortly. So clicking. Sound is a little bit off. Peter. All right. You are the first. So stay tuned. I'll need to collect your contact details so we can arrange shipping, and you will have the ability to pick the first color, because we have two colors. Let me just quickly grab them. We got blue and pink, so they're all yours. Well, one of them. Okay. Let's remove. And let's go for the second one. Alexander. All right. Again, we will exchange information for shipment, and then we get I would like to thank everyone for participating here. These are awkward times. You've probably seen around wearing the mask. We're doing this on location. So if you're you want to be a speaker at one of our events, we have a room that we get for ourselves, so we can actually manage this. So if you prefer to speak in front of a live audience, being Paul and me, yeah, you're happy to join us. If the distance is not making that possible, we would love to have you virtually within our midst. But that said, I give it back to Paul. Paul, you can do the closing, and then I will be in touch with the winners.
Okay, thank you very much, Michelangelo. Going to screen. Raffle time is so finally, there is just a thank you words from us. As you know, we things now a bit as kind of replacement for PHPBenelux conference. We cannot organize in these times if we want it. Anyway, we continue to do this. We continue to do this on a monthly basis, and we are trying to come up with an alternative for the PHPBenelux conference somewhat later than it usually is scheduled. We have no final ideas. We have no final ideas yet. We're just collecting a big agreement trying to go for something bigger online. And if possible, completely free. So. Okay, so thank you for. Okay, so thank you for thank you to the speakers. Thank you, Michelangelo. Thanks for sponsoring, and thank you all for attending. And see you next time. Bye.
Okay. Mag ik nog even afsluiten? Hè? Allee, ik kan niet typen. Oké. En dat was Peter Bottenberg, hè?
Ja. En Alexander. Ja.
Ja, cybercheck 67.
Kun je die individueel doen?
Ja. Ik zal met mijn laptop, die is nu momenteel aan het begeven.